Hello everyone, welcome to the class, and in today's class we are going to see the introduction to physical world. And Akshay, good morning. And today's class is going to be very simple. It's just your introduction to your physics, right? And again, today there's two classes because it's weekend. Today evening by around 4 we are going to continue from where we did on a measurement topic. All right, and let's begin. And once again, my name is Mohana, and I'm a physics educator at Unacademy. So I'll be taking your class 11 and 12 physics. And this is my Telegram link. And before going live for any classes or if there's any information, I'll be sharing in my Telegram channel. You can follow me for the same. And just like my Telegram channel, there's also a common Telegram channel for both ICSE and ISC both. So you can follow this channel as well. And how we have special classes over here in the YouTube. Similarly, we have special classes on the platform also. So the special classes in the Unacademy platform is completely free, and you can learn from any of your favorite educators. All right. So one of the interesting features we have is the pool features. So there we would basically, let's say you're learning a concept now. You can answer some questions based on this course on the concepts you learn through pools. So you can know whether you can understood the concept or not. And since the special classes are live, any doubts you have, you can clear then and there. And the next special class for the class 11, I would be taking this class. It's at 4 p.m. on 30th May. The topic is going to be Introduction to Impulse. Okay, you can use my code. You can actually use my code MTIS10. You can actually unlock this class. Okay, so this is an upcoming class. So there are other classes that is already I have completed on chapter 1 and also your unit 1, unit 2, and also few classes before this for your dynamics topic. So if you want to watch them, you can actually go ahead and watch it. So you can use my code again to unlock these courses. Now, other than free classes, we also have plus subscriptions. So you folks plus subscription, again, you can learn from the comfort of your home, and you will have unlimited access to all courses, right? You will get all the courses. For example, all of your subjects together, right? You can get unlimited access to all courses, and all the educators on Unacademy platform are good. So you'll be learning from top educators. And one interesting features we have is this doubt clearing session. So here what we are, every fourth class, let's say today I'm taking a class, and the fourth class from today, that will always be a doubt clearing session in your plus subscription. So first 3 days, whatever concept we have learned on the fourth on the doubt class, if you still have, okay, in the class itself you can get all your class clear, doubts clear. But in case if you want more explanation, in case if you haven't understood anything, if you still want more explanation, then you can again come and ask your doubt during the doubt clearing session. And in the plus classes, we will cover your entire syllabus. And also we have, for the plus subscriptions, we have the live test series. So in this test series, what you will be, every weekend we'll have this test series. So in case if you have attempt the test, basically the idea for this test is any concept you've learned, if you're taking the test, you can gauge whether you've understood the concept or not, or if you want to work more on the topic. So for that reason, you can try taking the live test. And after the live test, there will always be a analysis session. We are coming up with new batches for class 11, so do check out. Again, the pricing for the courses are actually low, but as you see, as the number of months increases, right? So if compared to the 3 months course, if you're taking a 2 years course, because you're in class 11, if you're taking for class 11 and 12 together, if you're taking a 2 months course, then the price per month goes down. Okay, so the longer duration course you're taking, the price per month goes down. And also you can use my code MTIS10 to get a 10% discount on any course that you're taking. If you're using any plus subscription you're taking, if you're using my code MTIS10, you would be getting a 10% discount. Okay, on that note, let's begin the class. So before we go ahead, what do you mean by science? So science is nothing but a systematic and organized knowledge about various natural phenomena which is actually obtained by careful experimentation. Okay, so in case if you want to know what is the cause behind the rainbow, right? So this the phenomenon would have been studied, some experiment would have been done on it, and then after systematically collecting more data on that, finally we would have come to an understanding of what was happening, what is the reason for rainbow to occur. So science is always about a systematic and organized knowledge about various whatever natural phenomena that is occurring around us. With this we have got by careful observation, right? By careful experimentation alone. Now, what are the types of sciences? There are two types of sciences in general. One is your biological sciences. Another is your physical science. Right? Biological science is very simple. It just talks about the nature of in biological science we basically talk about living organisms, right? All of your botany, zoology, all of it comes under biological science. Now this physical science is again divided into two branches. One is chemistry, another is physics. In chemistry, we usually study about, if you take any matter, we study about what is the composition of that particular matter, what makes up that particular matter, right? So when you're studying in depth about any matter that you have, right, about what is the structure, what is the atomic structure, how many protons are there, how many electrons are there, what is happening, what is the forces that is binding them, all of those mostly comes under chemistry. Yes, Akshay, chemical compounds, right? So, but on the other hand, physics, if you're studying, okay, physics is more of the study of nature and its phenomena. Right now, this class is possible because of current, right? What produces current, right? What is happening for the current to be produced, right? And rainbow, why is there a change in weather? Okay, why do we see seasons, right? That again, all of these things, right? The earth going around the sun, all of these, when studying any natural phenomena, right, comes under physics. So those are the two types of sciences. Now, anytime, whenever you want to do any experimentation, right, you need this right attitude. So that is, you need a proper scientific attitude, and a proper scientific attitude is nothing but it requires a flexible mind. Okay, so open-minded, you should be having an open-minded approach towards solving problem in which other important points of views are not neglected without any reason. For example, let's say you're trying an experiment and the experiment is not working. So you should be flexible enough and open-minded enough to try something else. Okay, so you try an experiment. If it works, you take the result. Okay, if it doesn't work, you should be able to have an open-minded approach to try a different method. You should be able to let go of whatever method you come up with and try a different method. So this would be the right scientific attitude. Now, there are some methods a scientific method has a step-by-step approach. Okay, a step-by-step approach is used by scientists in studying natural phenomena and establishing laws which govern this phenomenon is called scientific method. Okay, so what are these? What is the step-by-step approach? Is that first step is, if you're taking a large number of scientific exploration by doing a controlled experiment. Okay, anything if you want to do, right? For example, if you want to know how in a day, why a day has 24 hours. Okay, very simple, right? You can do this a very simple experiment, but you should have some control set of variables. Okay, and you should be able to do a large number of systematic observations. You cannot just say, okay, one day. Okay, if you want to see, like let's say if you just take a mirror, right? If you have a solar scope, if you have a simple solar scope, and if you fix a solar scope to one point, okay, and let's say today morning I have fixed it when the sun is here. If I've fixed a solar scope to one point, basically in this case what you're trying to do is you're trying to see what is the reflection let's say you have a setup in which the sun is getting the image of the sun is being basically getting as a reflection on a sheet of paper. Okay, so today at this point it was here. Okay, and you start a timer. Okay, tomorrow when so tomorrow at what time the image of the sun came back to the same position, you would be able to see. Okay, so then you can take how many hours you've done, how many hours, right, the time that took for the sun to take one complete sun for it to leave from the position that you've set up to come back. Okay, now this basically will give you this basically can tell you how many hours or what is the time it took. Well, why the sun takes 24, why the earth takes 24 hours to complete one rotation. But you can't just do this on one day. Okay, one day I've taken an experiment and that is right. No, but this can only happen. Oh, good morning. This can only happen when you're taking a lot of large number of observations, right? You have to take, you can't just do it for one day. You have to keep trying it. You have to take a systematic observation, has to be made for a longer duration. Okay, only then you can come into that any conclusion. Next step is you're going to study these observations and you're going to make some qualitative and quantitative reasoning. Okay, you should be able to apply whatever you're learning. You should be able to see, okay, this was the basic theory. I had an hypothesis, and whether that is basically the experiments I've done. Okay, is it giving me enough reasons? Or is it saying, okay, is it supporting my hypothesis or not? Okay, that is the next point you're going to see. Next, you're going to see, you're going to suggest mathematical models to account for this observed behaviors. All right. Not only this model that you're suggesting should account for whatever behaviors you've set till now, this model that you're suggesting should also predict new phenomena that you're yet to discover. Alright, and then finally you should have the right kind of a mindset to also modify the theory if necessary, if you're getting new evidences. Okay, so this is a step-by-step approach for a scientific method. Alright. Okay, now, okay, now, so what will be basically the scope of physics? I'm sorry, just give me 1 minute. Okay, the scope of physics, if you're taking, it is extremely large, right? We have wide amount, even if you're just talking about a basic fundamental quantities like length, mass, time, we have actually found out a wide range of lengths, right? We even know the size of an atom. The size of an atom, if you want to find we actually, 1 minute, right? Right? Right. If you're basically looking into the size of atom in terms of length, we know the size of the nucleus of an atom. Okay, nucleus of atom. This size of nucleus of atom is somewhere around 10 to the power of minus 15 meters. This is around 10 to the power of minus 15 is what we call as Fermi. Okay, and then from that to even we know what is the size, right? What is the size of the universe? Size of the universe is 10 to the power of 26 meters. This is your size of universe. Right? Now, we also know what is the mass of an electron. Okay, in terms of mass, if you're looking at what is the mass of an electron. Mass of an electron is so small, right? Electron is just an elementary particle, right? These elementary particle forms an atom. and from an atom you basically have your molecules, and then you have matter, right? So this forms a fundamental block. Like this is a extreme elementary particle. So if you look at the mass of the mass of the electron is around 10 to the power of minus 31 kg. To that, we also know what is the mass of a sun. 1 Fermi is equal to 10 to the power of minus 15 meters. That's correct. Right? Then to the mass of the sun, which is basically 10 to the power of 30 kgs. Right? And in times of time interval, okay, we also know what would be the time taken, right, by light to cross in a nuclear distance. Nuclear distance is in between your atoms, right? What is the time taken for it to cross? That will be somewhere around 10 to the power of minus 23 seconds. To what is the lifetime of sun, right? Sun also has a lifetime, correct? So just like all other the sun, basically the life cycle of a sun, our sun, since it's somewhere around average size, yeah, it will end up being a white dwarf. So sun also has a particular lifetime. And Sushil, good morning. And this the lifetime of sun is basically 10 to the power of right, 10 to the power of 18 seconds. Okay. Now, in spite of all of these understanding of your length, mass and time, okay, the complex physical phenomena involving that can be easily understood. Okay. There are 3 reasons for this. One is, just as we saw in the scientific method earlier, the reasons are extremely simple. One is the qualitative study of various natural phenomena, and there are some regularities and symmetry even in most of the complex phenomena, which helps us in understanding them. Okay. The second point that we usually say is, in spite of the enormous scale, right, enormous diversity of scales of natural phenomena, all of them can be explained by only terms of few basic laws. Though all of these are there, like you can explain all of these phenomena using basic laws. The reason why you are able to move on Earth is basically because of gravity, right? Now right, so this gravity is the reason why the Earth is going around the sun, right? So you can use basic laws to explain most of the major phenomena we are seeing around. Okay, in any complex phenomena that you're seeing, we can separate the more important features from less important feature ones. Okay, with this we can understand the complex phenomena in terms of more important features and unfold the simplicity hidden behind that complex phenomena. Okay, now just to make it's easy, for the sake of convenience, just for the convenience sake, okay, different phenomena, their properties, the properties of matter, energy occurring in different forms, can all be categorized and studied in different branches of physics. Alright, so the branches of physics are broadly classified into mechanics, okay, waves and optics, waves and oscillations, okay. Next comes heat and thermodynamics. Okay, next comes your properties of matter. Okay, this including fluid mechanics also. Okay, next comes your electrodynamics. Okay, next comes your optics and relativity. Right, next comes your atomic physics. Next comes your nuclear physics. Okay, next basically is your the other branches are basically electronics, and communication. And then you have astrophysics and also computer sciences. So these are the branches of physics that the physics is broadly divided into. Okay, now so every day we basically encounter some forces or another, right? Right. So there is a lot of examples or types of forces that we come across. We come across muscular forces, frictional forces, right? And also your elastic forces, magnetic forces we come across, electric forces and etc. Right? So all of these forces only include 4 basic types of forces operating in nature. Okay. So can anyone tell me what are the types of forces? Akshay, gravitational force, that's right. What about the other basic forces? Okay. Your electromagnetic force, right? That's another force. And then comes your strong nuclear force. And then finally a weak nuclear force. So these are the 4 fundamental forces in nature. Okay. So we'll study about all of them. First force we are studying about is your gravitational force. Okay. Gravitational force is nothing but the force of mutual attraction between two bodies by virtue of its motion. Now, for example, let's say there is one object, okay, you, and there's Earth, right? So basically, you are attracting the Earth with a particular force. The same way, the Earth is also attracting you with a particular force. Okay. Right, correct. When thrown up, they fall down because of gravitational force. That is right. So you have a mass m, the Earth has another mass m, right? The mass of the objects are different. The force acting between them, you can give it by the gravitational force. It has a constant g. Gravitational force has a constant g, right? And then it will be m, product of the masses, right? By what is the distance? Let's say this distance is r. By the square of the distance between them. Okay, so this gives you the gravitational force. What is the value of the gravitational force? If you basically know the masses, the masses of both the object, and if you know the distance between them, if the g is being a constant, we can find what is the force. Okay, so what are the examples? One is, as Akshay suggested, like, any objects when thrown up, they come down. That is because of gravitational force. Next, and also the next one is, what is the reason for Earth going around the sun, right? That is because of gravitational force. Now the moons or our satellites that's going around Earth, that's again because of gravitational force. Now your planets around the sun, this is also gravitational force. Free fall of an object on Earth, right? This is also because of gravitational force. What is the key reason for formation of stars and galaxies? This is also because of gravitational force. And these are the examples, some of the examples of gravitational force. If you know any other example, if you can come up with any example, you can share it in the chat box, right? So, what are the properties of this gravitational force? First of all, this force is a universal force. Universal force meaning this force exists everywhere in the universe. Okay. They act on even a very smaller particle, right? Small size of an electron to that of the large scale structure. Like if you're taking galaxies, all of them, right? Because of what is making the all of these all of these structures can be used, all of these natural phenomena can be is because of gravitational force, right? That so we can say it exists in large scale, so it is a universal force. Now, since it exists on the large scale, it's present everywhere, and since it exists on a long scale, right? So we can say it is a long range force also. Okay, even it acts between two galaxies. The distance between them is also long, right? The distance between sun to earth itself is long, but still we can see that gravity is the reason that earth is going around sun, so it's a very long range force. Okay, though it exists everywhere in the universe, it is the weakest known force of all the fundamental forces. Gravitational force is the weakest force. Okay, okay, and also again, this gravitational, if you want to measure, okay, what is the gravitational force, you can use this equation, that is F, the gravitational force. If you want to measure, this is equal to the gravitational constant into mass, okay, into the product of the masses, because gravitational force acts between two objects, right? Into what is the mass of the object, into the product of the mass of the objects, into the square of the distance between them. Now, if you have two objects, okay, let's say there are two objects, okay. Now, the force always acts along the line joining the two objects, okay, and the gravitational force will always act, okay. This object will attract this object will get attracted towards this one in this direction, and this object will get attracted towards this one, right, M2, right, towards in this direction. So the forces always act in the line joining the two forces, okay. Because of that, they are called as central forces. So whenever you have a force acting along the line joining the two objects, then we say it is a central force, okay. And also this force, if you want, okay, to calculate what is the force value, you can use what is the gravitational force, you can use this equation, okay. And here, if you see, F is basically proportional to 1 by r square. So from there you can say it obeys the inverse square law. Okay, so here the force is inversely proportional square of the distance between the object. So it obeys inverse square law, which means the strength of that force, as you go further away, the intensity of that particular force, right, decreases. The strength of the force actually decreases. Okay, and then gravitational force, okay, between any object is always an attractive force, okay, and these gravitational forces are always attractive forces, and the field particle of gravitational forces is basically called as graviton. The concept of exchange of field between particles, okay, between two bodies, explains how these two bodies are mutually interact from a distance, okay, but gravitons is not really a well understood concept yet, okay. Now, gravitational force is not only responsible for us to stay on. It is not just the gravitational force is not only responsible for us to be on Earth, right? We are still there. There is a force that is existed on Earth. It is not just because of gravitational force. Gravitational force is also responsible for any two bodies interacting from any distance. Okay, the binding, not only from the stars, that is the planets that is going around the solar system itself going around the galaxy, or the galaxies, the stars itself going inside the stars itself that are bound within the galaxy, right? All of these are the reasons of gravitational force. All right, so these are the properties of your gravitational force, and it's also a conservative force. Okay, so any doubts in gravitational force? Can I move on to the next force? Okay, The next force we are going to learn is about electromagnetic force. Now, the first chapter you would be basically learning in your class 12, not this year, next year class 12 will be electrostatics. Electrostatics is very simple. Right now, this particular class, or if you see, every day you're so dependent on electricity, right? So we I don't know if we can survive without electricity, but what do you mean by this electricity? Electricity is current. It's nothing but flow of charges, right? If you have charges and if they're flowing, right, if they're flowing in one direction, flow of charges, rate of flow of charge with time is basically called current. So it becomes very important for us to understand what the charge is. So study of these charges at rest is basically electrostatics, and that's what you will study in your class 12 first chapter. But now, the forces that is acting between two electric charges when they are at rest is basically your electrostatic force. Okay, and electromagnetic force includes your electrostatic force as well as the magnetic force. Okay, now basically if you have two charges, what do you mean by electric charges? Electric charges are nothing but elementary particles, right? What are the elementary particles? Basically, electric charges that we know are basically electrons. What we need to know, for now at least, there are many electrical charges, but what we need to know are electrons, then protons, and neutrons. This is what makes up your atom. So protons and neutrons forms the nucleus of the atom, and electrons revolve around this atom. Yes, Akshay. So can you tell me which one is a positive charge and which is a negative charge? Akshay. Right, when I said electric charges, Akshay had said positive and negative charges. So can you tell me what is a positive charge? Which one is a positive charge? Which one is a negative charge? Protons are positively charged, and that's right, electrons are negatively charged. Okay, right. Now, magnetic forces are nothing but the force that is because of a magnet, right? The magnetic poles, the force between the two poles of a magnet basically give you your magnetic force. Again, the force are not independent phenomena. Okay, over here, charges at rest, basically the force exerting between two charges at rest, basically you take two electrons, right? If these two electrons means these are the two electrons, let's say this is a charge, and let's say this is an electron, and this is also a charge and their electron, and in case if two charges are electron, they are like charges. Like charges will always repel. So this charge will exert a force on this charge in this direction. This charge will exert a force on this electron in this direction. Okay. Now, in case if you have similarly, instead of electrons, if you have protons, what will happen? They will also exert force in opposite direction. Okay. Okay. Now, in case if you have an electron and a proton you can also use E, right? Now, these two charges will attract each other. Alright, so these are the forces that is acting between the, these are the forces. These are the different ways in which the forces are acting between them. Okay, but when you look at a magnetic field, now there are two ways in which you can produce magnetic forces. One is, okay, the one is if you're taking a bar magnet, right? Any magnetic substances, then we know around this magnetic substance, right? Around this magnetic substance, there is a force. That is why there is a field, and because of that field, because the field is exerting a force on like if I keep a small piece of iron over here, actually I'll get back to your question. Okay, let me get back to that question. And over here, so basically over here, in this case, if you're looking at, if you keep a small piece of magnet, so a small piece of iron, right, it will get attracted towards the magnet. Why is that happening? Because there is forces around this, right? There is force around this particular magnet which is attracting it, right? Now that force which is attracting is basically what we called as a magnetic field. There is a field around the magnet which is exerting a force on an object which is pulling it towards itself, right? Now the force acting between these two poles is basically called as your magnetic force. But again, magnetic force can also be magnetic force are not just created because of magnetic materials, okay? It also formed by yes, Akshay, if you use iron filling, like if you take a magnet and if you basically keep iron filling around it, and if you tap on it, you can see the pattern of the field lines, okay? So that's true. And normally when you have, right, not only it can any, like a bar magnet, not only any magnetic substance can produce magnetic field around them, but if you have a moving charges, okay, when you have moving charges, the moving charges can form a magnetic field, okay? That's the magnetic effect of a current carrying conductor, you can say, because moving charge means current. Okay, there are two ways in which magnetic field can be produced. Magnetic field can be produced means there is a force that is experienced by an object that is kept over here because of that magnetic field. Okay, now the electric field and the magnetic field, right? The electric force and magnetic force, these are two different aspects of electromagnetic force. So the electromagnetic force themselves have some property. Okay, so these are some examples that are given in case of an electromagnetic force. These forces, electromagnetic forces, are stronger than your gravitational force, simply because these are contact forces. Anywhere there are contact between two objects, right? Whenever when you, let's say you're lifting a book and your book has you're in contact, your book has in contact with your hands, right? Then in that case there is the in the layer, right? If you just look at your hands, and then if you look at the book, there are atoms everywhere on the book, and as well as there is atoms everywhere on your hands, right? So gravitational forces act in such a case. It's because of the it's because of the electromagnetic force acts over there. It's because of the electromagnetic force that you're able to lift the book up. Okay, because why? Gravity is keeping the book, because of gravity, yeah, van der Waals forces, okay, in gaseous state, all right, okay. So here, but understand that though those are weak, that electromagnetic forces are basically stronger than your gravitational forces. Okay, now the reason, see, if there's a book, there is a gravity acting on it, right? So which is why it is down. So when you lift a book, you're applying a particular force, right? The force, whenever there is contact between two objects, then the force that is existing in between them is basically the electrostatic force exists between in such a case. One more way, if you want to experience what is an electrostatic force, it is very easy. Okay, rather than looking at all these examples, if you want to see what is an electrostatic force, if you want to experience an electrostatic force, magnetic force, obviously, you would have seen a magnet, right? Anywhere, anything you keep near a magnet, you would have gotten attracted. That is one thing. And because of your magnetic, because the current carrying, right, anywhere, the current carrying conductor can induce a magnetic field. We have many applications based on that as well. But if you want to simply observe what is this electrostatic force that we are talking about, right? If you just comb your hair, right, that is correct. Whenever you comb your hair, okay, what happens to that hair? If just comb your hair, if you have a very dry hair, long hair, just comb your hair. You used a plastic comb your hair. Bring in small bits of pieces of paper. Just bring your comb next to it. The bits of papers are actually down, right? So you have small bits of paper. What is acting on them is basically your gravity, right? Because of gravity, they have to stay down. But the minute you bring that comb next to this, right, you can see that this particular objects, right, they get attracted towards this comb. These objects gets attracted. So how do we explain them? That's because of your electrostatic forces. Okay, so from here we can say the electrostatic forces is much more stronger than your gravitational force. Okay. What are the properties of your electrostatic forces? Your paper gets attracted when rubbed. Yeah, friction. That electrostatic force acts because of friction. So rubbing is basically an action of friction, right? So that happens because of friction. What are the properties of your electromagnetic force? It can be attractive or repulsive. This is just because what is the positive? If it is between two like charges, right? If the force acting is on two like charges, then it will be a repulsive force. For example, if you're taking an electron, right, the electrons will repel each other. Or if you're taking protons, the protons will also repel each other, right? But if you take an electron and if you take a proton, okay, now these two will attract each other. So electromagnetic forces can be an attractive force or a repulsive force, unlike gravitational force, which is only attractive. Electromagnetic force can also be repulsive. Okay, next, electromagnetic force is given by Coulomb's law. Okay, Coulomb basically said he tried to make it as he tried to derive he make sure the equation is as it is analogous to the gravitational force. Okay, so according to Coulomb's law of electromagnetic forces, right, if you're looking at the electromagnetic forces, if you look at, right, this is given by your constant 1 by 4 pi epsilon naught. This is basically a constant quantity. This actually means the epsilon naught means permissivity of the medium, and it just talks about the nature of the medium. Okay, so if you have two charges, let's say this is charge q1 and q2. So this could be an electron and a proton, okay, or an electron or an electron, proton or a proton, anything. And let's say they are separated by a distance r. Okay, in this case, the electrostatic force acting between these two charges would be the product of the electric charge, right? The product of the charges by the square of the distance between them. Okay, now if you take two charges, separate them at a distance, okay, and if let's say if you're keeping them in vacuum, you will get a particular force. All right, now if you take the same system, keep that in water, the force value changes. Okay, but when we kept it in water, we did not change the charge, we did not change the value of q1 and q2, we did not change the value of r also. So what changed? The nature of that medium changed. That is given by epsilon naught. That is basically the permittivity. Okay, now so from here we can say that electromagnetic forces, they also obey inverse square law. Okay, these are also long range forces again. Okay, they can operate up to a large distance sufficiently. All right, right, Akshay. Difference from one medium to another. All right. Next is the central forces. Means here, whatever force is exerted, let's say if this is a positive charge and this is a negative charge, this force will get attracted towards this charge q2 in this direction, right, and q2 will get attracted toward q1 in this direction. So the force acting on them is a positive charge and this is a negative charge. This force will get sorry about that. Okay, so these two, right, and q2 will get attracted. Right, I'm sorry about this. The most right way to put it, Akshay, it would be like the both electromagnetic as well as your gravitational forces are central forces. Okay, next point is they are both conservative forces again. Okay, and gravitational force, So the electromagnetic force is 10 to the power of 16, 36 times stronger than gravity. Okay, so here which means this is the reason why, though there is gravity acting on that, when we took the bits of papers, right, and you comb your hair, right, so when you bring the bits of paper, comb near the bits of these bits of papers get attracted towards the comb, though gravity is acting on those bits of paper, which should actually, if gravity was stronger, the comb wouldn't be able to pick up these charged particles, sorry, papers, right. So here we can say this is one of the observation you can use to say that gravitational forces, right, are much more stronger than your weaker than your electromagnetic forces. So gravitational force is 10 to the power of 36 times stronger than this electromagnetic force is 10 to the power of 36 times stronger than your gravitational force. Okay, so again, the reason the field particle of electromagnetic forces is basically photons. Okay, and the photons, they have no charge, and then they has no rest mass as well. So the electromagnetic forces is the reason for the to bind the electron to the nucleus to form atom. Okay, and atoms bind together to form molecules, and molecule binds together to form matter. Okay, so this is about your electromagnetic force. Next is basically your strong nuclear force. Strong nuclear force, simplest if you want to understand, if you take an atom, if you take the nucleus of an atom, what are the charges inside the nucleus of an atom? So basically you have your proton and you have your neutron, correct? So these are the charges inside your atom. But protons are positively charged. Neutrons has no charge. Okay, neutrons have no charge. Okay, they have no charge. Right, but protons has positive charge. Okay, so according to what we learned in electrostatic force, like charges should repel each other. That's right, actually like charges over here should repel each other, right? But what is keeping those like charges inside a nucleus? There's so many protons, so according to us they should repel each other, but what is keeping these charges held together? Okay, that particular force, though these are positive charges, the charge that is keeping these two, the charge which is basically keeping your protons and nucleons, right, neutrons bound inside the nucleus of an atom, is basically that force is a strong nuclear force, and it's a strong attractive force also, because it's binding all the objects and keeping them. Okay, and alright, now this particular force is strong nuclear force is seen in to bind together protons and neutrons. Okay, the example is basically, since they act in such small distances, radioactivity in nuclear in nuclei, that is because of your strong nuclear force, and your nuclear energy because of both fission and fusion, this is because again of strong nuclear forces. Okay, then okay, so where do these forces basically act on, right? This is the strongest interactive force that we know in terms of nature, right? And these are 10 to the power of 36 times stronger than gravity, much stronger than your electromagnetic forces. Okay, then these are short range forces. Why do we say these are short range forces? They act in the range of 1 Fermi. Why do we say that? What is the size of a nucleus? The size of a nucleus inside an atom, right? Inside an atom, the size of the nucleus where proton and neutron are there, that size is somewhere around 10 to the power of minus 15 meters, 1 Fermi, right? Because of that, this is a very short range force. This doesn't apply on long ranges. Okay, and it's an attractive force. Basically, this force is binding. Okay, this force is acting between your proton and proton inside a nucleus, or a neutron and neutron inside a nucleus, or a proton and neutron. Okay, it is what binding all of these protons and neutrons inside a nucleus. Because of this, we are calling it an attractive force. Unlike electromagnetic force, electrostatic force, it's not repelling them. It's an attractive force. Okay, and in case the repulsion between them happens when the distance sort of goes higher. Okay, And so from here we can say this particular force, right, this particular force, it is a non-central force. It doesn't act along the line joining the two forces, and it's also a non-conservative force. Okay. Okay, so basically, as I said earlier, we apply only on a very short range. If the size increase, then again the force itself becomes repulsive. Okay, in this case, the field particle in this case, the field particle is basically pi mesons. Okay, these are again elementary particles, much more elementary particle. You may not have seen about them. Now the nuclear forces, right? Right, if you're comparing this particular nuclear forces, the strength of this particular nuclear force, then right, if you're comparing the size of this nuclear force, here, this particular nuclear force, right, if this, we're just looking at the relative magnitude. Let's say the relative magnitude of your gravitational force is 1, okay. Compare the gravitational force with the weak, we have one more force to study, that is the weak nuclear force, okay, weak nuclear force. The weak nuclear force is somewhere, when compared to gravitational force, it will be 10 to the power of 26 times greater. Then you have the electromagnetic forces, right? Electromagnetic forces when compared to gravity is 10 to the power of 36 times greater. When compared to that, if you look at strong nuclear forces, right, it is around 10 to the power of 39 times greater than your gravity. We are saying 38 to 39 times. Okay, so if you look at this forces that is acting in this case, right, the strong, so weakest is gravitational force, then your weak nuclear force, then your electromagnetic force, then comes your strong nuclear force. The force that is binding the protons and protons, neutrons and neutrons, or protons and neutrons inside a nucleus is the strongest known force to us. Alright, next comes the weak nuclear force. Now the weak nuclear force, okay, these forces appears only between elementary particle in a nuclear process. Okay, and the weak nuclear force is the reason. Okay, this was basically the study discovered. Weak nuclear forces were basically discovered during the study of beta emission from a nucleus. Okay, so these charges, they have no charge, they have zero rest mass. Okay, and so the force that appears between elementary particle in a nuclear process, especially when a beta decay happened, what happened, right? A radioactive nuclear transformation governed by the weak force in which the nucleus, such as the neutrons, okay, such as the neutrons, change into a nucleon, such as a proton of the other type with the emission. A neutron changes into a proton with an emission of other, another, similar to an electron and an anti-electron or a positron or a neutrino. Right, that's right, by emitting an electron. Neutron changing into a proton by emitting an electron. This is basically beta decay. The weak nuclear force is observed in such a place. A neutron changes into a proton, right? It gets converted, right? In which it changes into a neutron plus an electron, okay, and some antineutrinos or positron or a neutrino along with that. Okay, Ritik, hello Ritik. Okay, so this is where your weak nuclear forces apply. Okay, now this weak nuclear process, what are the processes? Okay, so weak nuclear forces, what do? They always cause the lighter elementary particles. Okay, they make them to interact with one another and with heavy particles. So the weak forces are the forces which cause lighter elementary particle to interact with one another and with elementary particle. Ashu, right, hi. Ozar. Okay, so that basically means your antineutrino. Okay, so again, these process involves neutrinos and antineutrinos. These are 10 to the power of 25 times stronger than gravity. They again operate in the range of the nuclear size, which is basically 1 Fermi, 10 to the power of minus 15 meters. Okay, so here they say messenger boson that transmit the peak forces between the elementary particle are massive vector bosons. So more about the elementary particles, you might study a little bit about them in your class 12, but not much. For you, the main concept is going to be mostly on electrons, protons and neutrons. Okay, and good morning. And so what are the basic mechanism of the fundamental forces? The basic mechanism for the fundamental forces to arise is due to exchange of particles, right? In electromagnetic forces, this is because of exchange of protons between two charged particles like electrons, right? And in case of weak nuclear force, it is because of exchange of massive particles called vector bosons. And in strong nuclear force, it's called because of exchange of meson between two nucleons. Okay, now the rest we would continue. The conservation, there are certain conservation laws, that is laws conservation of energy, law of conservation of linear momentum, law of conservation of angular momentum, and law of conservation of charge. These we will learn in the upcoming classes. I'll try covering them with part of your measurement topic as well. Okay, so with that, let's come towards the end of today's class. Okay, and here we have the upcoming plus batch. It is going to start only from 8th June onwards. Okay, and for physics I would be taking, for math Jyoti ma'am would be taking, Manisha ma'am will be taking chemistry, and Lakshya sir will take biology. For physics we will meet every Tuesday, Thursday, Friday, Saturday between 5:15 to 6:15 p.m. and there is a number given in the description box. You can call them to get more details also, right? And also if you can actually in this case, the course, this is the first batch that is starting. The course itself will start only from 8 June onwards. The target of this course is going to be your midterm coverage. So basically we will be looking into your the volume 1, right, or your term 1 syllabuses in this course. Okay, and community is one more feature we have in the Unacademy platform. So this is my community link. So you can follow any educators, any of your favorite educators community, right? You can share your feedback directly with the educators via poll also. If you're following my community, there will be a few questions asked there. You can try and answer. All right, and also Bucks Bounty was one more feature that Unacademy came up with. In case if you're watching, and if in case you see any inappropriate content, yeah, okay, and if you're reporting the issue, then you can claim a prize. And thank you for taking the class, and you can actually click on the bell icon to subscribe to the channel so that you know when is the upcoming classes. Today again we have another class at 4 p.m. for class 11, so subscribe to the channel so you can stay updated on whatever the topic is, and also like and share. All right, and looking forward to seeing you in the next class, and bye Akshay. Okay, if you don't have any questions, I'll end the class.